In this video we shall discuss how to manage graph structures. Before we begin, we have to make some preparations. It is we have to create such tables. The first table will contain information about cities with city ID and city name. The second table will contain information about connections between cities. That information will include the source point, the destination point, the cost of transfer between that points, and there also will be information about if this connection is bidirectional or not. We see that for all three DBMSs those structures are the same, and then we shall store the following data there. Here we see our cities with their IDs, and we also see connections with transfer cost. And we also see several bidirectional connections here and single direction connections. Once we store the data inside our tables, this is how those tables will look like. Now we may proceed with tasks, and in the first one we have to enhance the data model, so for bidirectional roads one can swap from and to cities and still find the road. The idea and the expected result here is the next. Imagine that we have two queries. Here is the query 1, here is the query 2. And we have a connection between cities 1 and 5, and that connection is bidirectional. In the first query we are using the city 1 as the source and the city 5 as the destination. And in the second query we are using the city 5 as the source and the city 1 as the destination. But both queries should return bidirectional route between these cities. That means that both these queries should detect this route between these cities, because that route is bidirectional. The solution for all DBMSs here is the same, and it is based on views. Let's start with MySQL. Here we have to create a view that is based on the following query. First we have to select all connections, and then we have to union that result with the result of another select query. In this query we are selecting only bidirectional connections, and we are swapping to and from points. So in the first query the from point is on the first place, and in the second query it's on the second place. And in the first query the to point is on the second place, and here it's on the first place. And finally let's look at the data. Here we see the connection between city 1 and city 5, and it's bidirectional. And this line is produced by this query. We see 5 here and 1 here. And now we may easily look for connections from city 1 to city 5 or from city 5 to city 1, and in both cases such a connection will be discovered. The solution for Microsoft SQL Server is the same. Here we also creating a view, and in that view first we are selecting all connections, and then we are selecting only bidirectional connections, and here we switch places for this field from the second one to the first one, and for this field from the first one to the second one. And for Oracle the solution is also exactly the same. Here we also creating a view, and in the first query we are selecting all connections, and in the second query we are selecting only bidirectional connections, swapping that places. In the second task we have to create a stored procedure to find a route between two given cities, and if such route exists, to calculate the total route cost. The expected result for this task is the next. Imagine that we are searching a route between cities 1 and 6, and we see that there are two variants here with the following costs. If we use the graphical representation, we shall see the following picture here. From the city 1 we may go to the city 7, then we may either go to the city 3 or the city 2, and finally we may go to the city 6. Also for this route we have that cost as 31, and for this one we have that cost of 85. Before we begin we have to make a disclaimer here. Yes, the following code may not look simple. Yes, relational DBMSs are not good with graph data processing. But still there is a possibility to make some tricks and achieve the goal. Let's start with MySQL, and here we shall review our stored procedure step by step. First we have to pass two parameters to our stored procedure, the ID of start node and finish node. It is the starting city and the destination city. Then we have to declare a variable. That variable we shall use in a couple of seconds. And then we have to create a table for temporary route storage. But here is a warning, please make sure that you don't have another table with this name. Otherwise you may break something in your database. Then we have to drop that table if it exists, and we have to create that table. The table will contain data about source node, destination node, the route cost, the information about if this route is bidirectional, how many steps it contains, and the route itself. Now we have to fill this table with all existing routes, and on the first step we have to fill this temporary table with already existing routes from connections table. So we are selecting the data that was described in details in the first solution, and we put in the data into our temporary table. On the second step we have to produce all possible routes and store them in our temporary table. This row count function in MySQL returns information about how many rows were inserted with the previous insert operator, and on the previous slide we've made that insert. So for now the value in this variable is not 0. And then we shall start the loop and use that variable as the information about should we exit from the loop or should we not. We should exit when insert operator will produce 0 inserted rows. That means that we found all possible routes and stored them in our table. Now let's review the selected data. In this part we are selecting the source and the destination nodes from two tables, from our temporary table and the initial connections table. So imagine a situation when in our temporary table we have such a record, for instance from city 17, this part is not important. There is a route to some city 19, for instance, and this part is not important either. And that information is stored in connections table. Of course, we have to somehow connect these records, but that information will be shown in a couple of seconds. Then we have to calculate the route cost. So, for instance, if this cost is 5 and this is 50, the result is 55. Then we have to find out if the resulting connection is bidirectional or not. It will be bidirectional if only two of these conditions are met. It asks this connection should be bidirectional and this connection should be bidirectional also. Then we have to increment the steps count. It asks if from city 17 we are going to some another city and then to city 19. That's the first step and that's the second. And then we have to store the route itself. It asks we have to produce something like 17, then something, and then 19. And speaking about this something, we shall go to the next slide. Here we are joining the information from our temporary table with the information from our connections table. And yes, here we are also using the same idea we've already seen in the first solution. Now let's talk about that question mark we've seen on the previous slide. Imagine that in our temporary table we have the following connection from city 17 to city 21. And in connections table there are several records, like for instance 21 15, 21 19 and for instance 21 17. Due to this condition, all these three records will match that record. But this condition will disallow this record from getting into the final dataset. That's because otherwise we'll get infinite cycle, like 17, 21, then 17, then 21, and so on and so on and so on. And we don't need such cycles in our dataset. Then we have to combine this new data, like pairs 17, 15, 17, 19, with data already existing in our temporary table. But we only have to put the data there without duplication. And then we have to check how many rows were inserted in our temporary table. If the answer is 0 here, we have to exit the loop. And finally, when all routes are produced, we only have to select those routes that have the same starting and the finishing node as the start and the finish point passed to our stored procedure as parameters. We also have to mention that this approach has two disadvantages. The first one is that we have produced all possible routes, and that's extremely slow. And the second disadvantage is that this approach only finds alternative routes with equal length. If there are alternative routes that are shorter or longer, those ones will not be found. Of course, there are alternative solutions, so if you are brave enough, try rewriting this solution using depth-first search approach. Finally, to test this solution in MySQL, we only have to call our stored procedure, passing the source and the destination IDs as parameters. The solution for Microsoft SQL Server is the same, so we shall review it briefly. Here in our stored procedure we also have to input parameters for the source city ID and the destination city ID. We also have to declare that variable that we shall use in a couple of seconds. Then we have to drop and create our temporary table to store all routes. Then we have to copy all existing routes into our temporary table. And then we have to start the loop following the same exact approach as we've seen with MySQL. And here in this part the approach is once again exactly the same as for MySQL. And this final step is once again exactly the same as for MySQL. We only have to select corresponding routes from the table containing all possible routes. Testing this procedure in Microsoft SQL Server is easy. We only have to execute the procedure passing the IDs of the source city and the destination city as parameters. In Oracle, we also need this table to store all possible routes. But due to a lot of Oracle limitations about temporary tables, we have to create this one separately outside the stored procedure. The rest of solution for Oracle is exactly the same as for MySQL and Microsoft SQL Server. Inside the procedure we have to copy the initial data about all routes into our temporary table. Then we have to use the same approach for this while loop, and inside it we have to take the information from our temporary table and combine it with information about connections stored in that table. Once again, this idea was described in details in MySQL solution. And finally, on the last step, we have to select those routes that have the same starting and the destination points as was passed as parameters to our stored procedure. In Oracle, we cannot perform a direct select here, so to test this procedure, we have to execute such a huge query. We have to declare several variables, then we have to execute our stored procedure, and then we have to execute such a loop. On each iteration of that loop, we shall take one line from the stored procedure result, put it in these variables, and then we shall print that variables to the screen. As it's absolutely clear that all these solutions are not simple, please pause the video and try to create all those stored procedures in your DBMS, execute them and investigate their behavior.